Welcome to the Legacy Series. I'm your host, Jeff Nally, and our guest is Dr. Fred Whitford from Purdue University. And the title of this program, Doc, is called Don't Spring a Leak. What are we talking about?
All right, we're going to talk about hoses.
Gee.
Just a simple old rubber hose.
Not all hoses created the same, not all have the same applications, and not all carry the same product.
That's correct. So the idea here is you look at this piece of equipment, how many kinds of hoses would be on it. Hoses that run everything from the inside of the truck, which the mechanics are always looking at, to hoses on the tanks, hoses on the sprayers, hoses all over hooked to pumps. Lot of hoses. Cheaper component of most of these sprayers, but it's also the one that we typically ignore until it breaks.
$400,000 piece of equipment will sit still in the field with a hose that's down.
Paying somebody to sit there waiting on a hose, and depending on what time of the day, depending on where you're at, you might be waiting a lot of hours, time that you could have been making money and controlling weeds, insects, and diseases.
There's also an environmental aspect of this as well, that if the product that this hose is carrying breaks and now there's a spill into a field or into a watershed or into a stream, now we have a bigger issue.
Right. You didn't have time to check the hose, but you're going to have 6 months to worry with regulatory people about fines, penalties, and depending on where it's at, lawsuits. So, you know, as you said, spend a little money now, spend a little time now to take a look at this. It's pretty simple, it's very easy, but it's often checking hoses a neglected piece.
Not all hoses are the same. They have different specifications and requirements. So what questions should we ask? What should we know?
There's 13 questions, and most of you'll know that when we go through it. We're going to go through the questions, but the last one, point number 13, is what it cost. Notice that that's at the end, because what we want to be able to do is compare apples to apples. And so I'm going to ask certain questions to make sure that the man or woman behind the counter is prepared to answer my questions, and if they can't, they'll look in catalogs. But you don't know if the man or woman's been there 1 week, 1 month, or 50 years. And so I don't want to leave this to people who are inexperienced.
Safe to say, don't assume.
Don't assume. It's always the best thing. And it's just, people say, it's just a hose. Oh, it's just a hose. But let that hose go down. And a lot of things can happen and does happen. So, you know, obviously what materials will it carry? Some of these hoses can carry water. Some of the hoses carry air. Some of the hoses carry fertilizer. Some carry chemicals. Some carry manure. These hoses are made of different materials, and if you can see here, as this material goes from the inside and breaks that first layer, you start getting into the main part of the fabric of the hose, and you can see the pimples, the bubbling here, where the chemical is actually breaking it down.
So this hose might have been adequate with the pressure that it was carrying, but the inner core of the hose wasn't built for the corrosive nature of the product it was carrying. You can't also assume a hose that was meant to carry water is going to carry gas effectively as well.
That's correct.
You need to know what's going inside the hose and as well the environment that it's going to be operating in.
And that's why that's the number one question is, that will this hose carry whatever it is that this hose is carrying when you're talking to the person behind the counter. The second most important piece is what's the pressure it's got to withstand. I think you were saying on your spray that you've got for your crop, you're looking at, what did you tell me, 30 to 70?
In our application, we're looking with pressures between 30 and 75 pounds a square inch. But here's obviously a hose that's going to carry a lot more pressure, probably a hydraulic hose, 4,000 PSI.
Yes. And obviously then, wouldn't one be more expensive? 200, 4,000. Wouldn't you think there would be a difference in the hoses and ability to hold that pressure?
Yeah, whether you want to be broke down once or twice. I mean, here's an example as well in a hose that says it's got a working grade at 600 PSI, but it also has a 1,800 pound burst.
Yes. So what the manufacturers do is they're telling you what these hoses will normally operate under, what pressures are typical pressures. That's your 30 to 70. They're also saying that sometimes things go bad, valves don't open up, just the pressure just builds up. And so it's normally about 4, this one's about 3, and Anhydrous I think is 4 or 5 times more pressure that will actually just blow it out. So it's a safety margin built in.
So if you told the person behind the counter, I need a hose that'll carry 600 PSI, and you carry that home, fine. But if it's not prepared for the burst at 1800,
That's correct.
you're broke down again.
You're broke down again. And under these kind of hoses, when you lose a hydraulic, people actually can shoot through hands. I mean, these are extremely high, dangerous pressures. So that's another component. What does it carry? What's the pressure? The more expensive, you can see here, I start adding various layers. There's my inner core. That's going to carry the chemical. Now I'm going to reinforce it, and you can start seeing I start adding wires, I start adding components. This one here, you can see I've got this thing banded with metal. It's like a cage.
All important for the exterior, all important for the interior, and this comes from understanding the specifications that this hose has to operate in.
That's correct. What is it going to carry? What's the pressure, are the two big ones. Now, the other one, which you'll make this mistake once, has to do with the suction hose. So as I'm putting from the pump out, that is just pressure building up. But if I'm from the tank to the pump is sucking, it's pulling, and it's trying to collapse it. So that's why you have a suction hose that has, as you can see right here, a lot of ridges on it, which prevents that from actually collapsing. So is it on one side of the pump or the other? There's a difference on the how this thing's made.
On the draw or on the exhaust?
That's correct.
Is it, which side is it operating on?
Which side is it on?
That's a question you need to ask.
Yep. And then you have the clamp. They're going to need to know what diameter, and you can see here on your side, Jeff, you got
The outside diameter of this pipe is 5/8 of an inch, but that's not the situation on the inside.
That's correct. On the inside, you can see the inside diameter, and it's going to have to go over a fitting, and so you need to know that, obviously. And then we always want to try to cut just a little bit extra, because these hoses do flex, they do pulse, temperatures can change things. So what we try to do then is to always cut a little bit extra to give it just a little bit of flex.
And if you think about a tractor or another machine that you might be using in the dead of winter when the temperature is 20 below, or in the heat of summer when it's 100 degrees, you've got to make sure that hose has room to flex with the environment that it's in.
With the environment that it's in. And then one of them, again, you only make this mistake once, you've already spent the money. If you notice here on these booms and other places, when I fold it up, you can see that based on how it's designed, how it's kinked up here, which really screws up the hose. It screws up how, when you unfold it, many of these will remain just collapsed that way, and it screws up.
You make physical damage to the hose that it never recovers.
And it doesn't recover, like a coat hanger. And here you can see on your upper left there, you can see where it's trying to bend it. So these hoses, is it going to have to bend? Is a question. Is it going to be an area that you've had maybe leaks, petroleum leaks that you can't fix, diesel oil, hydraulics, because I can leak from inside of the hose out. I break that cover and I get up into those strands. Or in this case, if you looked at it, can you see where the petroleum is actually eating the cover? And so now what I'm doing is working it from the outside in, and I'm going to start eating into whatever that protection is around that core. So I'm actually breaking them both, one from the inside, one from the outside.
So not only do I need to know the specifications of the hose and what it will carry, but also the environment that it's operating in. Some hoses better prepared for this than others, or maybe we need to find a better place to run that hose.
Yes, or maybe get a shield for this if I can't fix it, to keep that petroleum, because petroleum, unlike gas, is not going to blow off and turn into a vapor. Again, you start seeing things like this, Jeff, and we talked about common sense. And you know, I understand you want to get your money's worth out of a hose, but when you start seeing equipment like this, you know, something's not right, and I shouldn't be running equipment like this.
Well, first of all, for the inconvenience of downtime, but the second of all, if this is a lifting mechanism, a backhoe or other, where it's where you're using it under a strain, and there are people that are involved, the damage that can come to persons or to property or other, This is clear. This is a visible exposure for one reason or another, and now this is
But
compromised.
that didn't happen. That didn't happen yesterday.
Yeah.
This has been going on for a long time.
Chances are it's not going to heal itself either.
That's correct. I mean, it's just going to get worse as we go. And then, like any rubber products that we have, as we were talking about, a lot of our tires don't wear out. The tread's still good, but it wears out based on age.
Right.
And this rubber dries, and when rubber dries, you begin to get these cracks. You begin to get things like this typical example here, where now this hose is brittle. It doesn't have the flexibility. I'm pumping stuff through it, and so this hose is shot. It needs to be replaced. What physical environment is it going to be in? If you looked at this here, is it going to be rubbing on stuff? And hopefully it's not. We'll talk about that later. But can we do something here? And obviously, if it's rubbing into the bands, into the outside protection that holds that inside together, then obviously that's not a good thing. And whatever the PSI this hose could actually hold is not going to be able to hold it, because I'm actually tearing out the reinforcement.
And if it's in that challenging environment, there might be an option maybe to spend a little bit more on the front end for a better hose to operate and function in the environment that's going to be placed, or again, take other measures.
Take other measures. And then the weight of the hose. Sometimes, if I'm going from a tender truck to going to fill up a sprayer, or if I've got hoses around the plant, maybe that weight is an issue. So I want to see what that hose weight. It's all in the specs. All this is spec'd out in the catalogs. There's different kinds of clamps, and understand that Jeff, we can lose something through a hose, eating it from the outside, the environment, or from that core, it penetrates and comes out the other way. The other one gets blown off the barbs, off the fittings. So
and there are different types of clamps as well, made from different material. Now, some might look at this and say that's a radiator hose clamp. You suggest this is a worm gear clamp.
Yeah.
There are others that might be more effective.
You betcha. And so the worm gear clamp is because I can just screw it in and it moves. It's nothing but a screw. But it sounds better. I am putting all of this pressure on a hose, worried about human health, inconvenience, spills, all of these major issues. These are not minor, trivial things. So we really like the T-bolt clamps, and even these particular clamps are probably the highest level clamp you can get. And I don't know, you could probably go from 50 cents to $6 to probably another, with the tool, $6 or $7 there as well. Sure, you're spending more, but the consequences of downtime is just amazing.
You get what you pay for.
You get what you pay for. And then, you're wanting to know what kind of fittings am I going to be needing. And if you notice here, depending on if you're trying to hold the hose to the actual fitting, obviously the clamps help. But if you notice here, I've got different depth of the grooves. And so if I need to penetrate the outside of that hose to where it helps to hold the hose to the fitting based on these, then that's another issue.
And as is depicted here, here's a barb that has pipe fitting here, but it's not just one, it's two different ribs. A great place for a clamp here and a clamp there.
You betcha.
To guarantee your hold.
And that's what we want, to guarantee no spills and to guarantee a hold. And then that gets us to the last, is what does the hose cost? It's like buying a pickup truck. I can buy a pickup truck and say, how much does yours cost? F-150. Or I go I look across all the different, and I say, how much does your truck cost? Well, you get all these different prices. Might there be differences in those trucks? What they come with, what they equipped, how much they can pull? So we don't buy pickup trucks like that. We ask questions. And then then I maybe narrowed it down to 2 trucks, and from those 2 trucks, we buy the one that meets our needs better for the price, value.
So we've had the opportunity here at this series and this point in the conversation to ask the right questions to get the right product. So now we're going to move over to the table, bring in a local expert with a lot of experience in hoses and specifications to get up close and personal with some of those to help you make better choices. Don't spring a leak.
Well, Gary, Grant, thank you very much for coming to help us today. And
Good to be here.
Gary, you're with Ohio Valley, and my understanding is you've been in this ag equipment business for a long, long time.
Yeah, I started in the ag equipment business in 1975
So you've seen just about everything there is to see when it comes to hoses.
with all the good and the bad both in the hose industry.
You bet. So I thought what we would do is to sort of get your some of your experience, and you could teach us a little bit about inspection, some techniques and stuff that we should pay attention to. And so I thought we would start off with this particular hose here. This is a suction hose meant to go from between the tank and the pump, and the idea was it's reinforced. So when I'm drawing out, the pump is drawing into it, it's creating a vacuum, and so it's reinforced. I mean, but what can go wrong with these hoses?
This particular hose is an Epdm reinforced hose.
Now, does that mean rubber
That means it is an Epdm rubber liner.
Okay.
Inner tube is rubber, and that is what you're seeing in between the reinforcement here.
the black piece?
That is actually the inner liner.
Okay. So
this-
there's no reinforcement. I mean, there's nothing. There's not an extra cover on it.
No,
This is
there's no outer cover or safety, whatever you want to call it.
You bet.
The design of this hose is a suction hose,
Okay.
and because of that, it will pull a full vacuum with a nylon braid holding it. It's a good hose for what it's designed for. The biggest thing you have to look for here is for the EPDM to start breaking down.
Okay.
And a quick and easy way of doing that is strictly to bend the hose around to where you can see the liner. And what we're looking for is what I call spider cracking or dry rotting.
Yep.
And if it's reached that point, you'll see it immediately when you bend the hose over like this, because it'll start showing up at the edge of these reinforcements quickly.
Okay. So is that kind of like the dry rot? I call it dry rot on tires. That the tires gets old, you start seeing that cracking.
That's the
same thing.
Exact same thing. And that's what you want to look for here, because when that happens, this hose will start leaking.
So this was from sunlight damage.
Yes.
So in the scheme of things, when it comes to most rubber type products, is sunlight our number one enemy?
Sunlight on all rubber hoses is our number one natural enemy.
Okay.
Misuse and mispositioning of a hose can become a number
Sure.
one quickly.
All right. Now, we got a real solid hose here. Let's look at this hose right here and tell me what about, I mean, it looks like a plastic hose, but it's not, is it?
This hose is a nylon material. It's primarily designed as a sight gauge hose in our ag industry. It's used for a lot of other things, but it is a very low pressure. This hose is not designed to be sprayed through with anything, be it water or anything else. It's not designed to carry pressure. It works very well for what we design it for. It's used for a lot of things it shouldn't be used for, and it causes this to break down very quickly.
Again, sunlight is another.
Sunlight is terrible on the nylon hose, absolutely, but chemicals will actually soak into these hoses.
And again, when that soaks in, then we begin to destroy some of the integrity of the hose.
Exactly.
Okay. Well, in fact, I got this one here. Looking at that particular one here, what?
This hose obviously has had material run through it that is not compatible with the nylon construction of it, and as you can see, it has just caused the hose to literally disintegrate.
I can just break it
And,
apart.
just taking your hands, you can bust it open.
Okay.
And you can imagine what would happen if you had this under pressure in that kind of position
betcha.
and condition.
So that's why we say, if the hose becomes discolored, that might be a clue. That might be a clue for you.
This type of hose especially.
Okay. And if so, these kind of hoses, are we saying it's because they're relatively inexpensive? I mean, they do well for what they're meant to do, but replace them once a year?
I would, yes, absolutely. Even as a sight gauge where it's not under any extraordinary pressure, they're cheap. Don't chance something going wrong with
You
them.
betcha. Now, obviously, then we start looking at what typical rubber hoses are what we have, and I'm looking at this one here, and we have the inside liner, which we're going to call the inner tube, and for the most part, your experience says as long as we got the right material here, we can run, these hoses can run most of the chemicals that we have?
Again, this is an Epdm hose, which is the most common hose in the ag industry. It will handle the majority of all chemicals out there. The Epdm will actually handle the majority of them at full strength.
Okay.
But at a hose such as this one, a lot of times we see them after the chemical has been dissolved in the spray water, and thus it's at a very low percentage-wise. This hose is a suction hose in its own right because of the double nylon braiding that we have here. It also has a wire reinforcement through it, which gives it the capability of pulling a full vacuum and act as a suction hose. But with this nylon braiding and the wiring and the outer skin around our inner tube, it's also a higher pressure hose. And it can be used on the discharge side of pumps, on sprayers and transfer trucks both.
Based on our experience, again, we're saying this particular hose, it would be difficult to actually have chemical eat through it and break it. So most of it would come from the outside?
As far as inspection and what you're looking for is damage to the outer skin.
Yep.
And when you see that, what's happening is, again, this narrow, thin layer of inner tube is not designed to handle pressure. So if we cut through the outer skin and through the nylon cords, this inner tube is going to blow out just like a balloon.
So wherever that cut or that hole is, that rubber is going to try to push up out of it.
Exactly.
Okay. So what we're looking for then is anything on the outside that looks like it could damage this outside shell that's protecting the inner tube.
Yeah, we're looking for obvious, damage to the hose itself.
So let's take a look at this one, spray hose. So let's talk about this one.
This is a nylon braided spray hose. This is typically what you'll see on all type of sprayers, pull type, self-propelled both, and it's got a pressure rating just like everything else. What we're seeing, and again, we look at the end, it's a double nylon braid.
I see the core, one set of braid, and it looks like something's different on the outside. So it's 2 layers.
We have the inner tube.
Yep.
We have the 2 braided sections, and then we have what we call the skin, the outer layer of the hose itself.
Okay.
And on this particular one, it's obvious this has been on a sprayer or something where it's continually getting a rubbing action here.
Yep.
And it literally has eaten through the outer nylon braid. By doing that, this hose, the working pressure of this hose has been cut by more than half.
Because I've taken 2 of the layers, kind of, right?
Right. We've taken the outer skin, we've taken the first nylon braid, and we are starting to wear into the rubber where the second nylon braid's at.
So that's a replacement.
Yes.
Okay. Now, what becomes even more dangerous is something like this one here. And I think what we had done, we had actually opened it up, and I can actually see wires and stuff here.
You'll see broken wires here. This hose is an accident waiting to happen.
But what's special about this hose? I mean, just by looking at
the hose itself is obviously a very high pressure hose, such as a hydraulic hose. It's got multiple steel braiding in it. At the pressure these type hoses run, a cut like this one is just dangerous, because anything that escapes through here, you got to remember that hydraulic oil could be running through here at 2,000 psi. Well, at 2,000 psi, a hole the size of a pencil lead coming out of that hose could literally blow right through your hand.
So while we have on this one, to kind of go make this comparison, this one here I've eaten through the skin, 1 layer, and it's going to hold up. I still got 1 more, though I've lost a lot of the ability to hold the higher pressures. And so we want this replaced, but this one needs to stop and be replaced immediately.
This hose, if I found this at lunchtime and I was going back to the field to spray, I'd finish the day probably.
Okay.
But tonight when you go to the shop, let's replace it. This one, immediately. This has obviously been pinched and cut, and an accident waiting to happen.
All right. Well, we can make repairs, and tell me about this one here.
Well, this is the obvious. I'm in the field, and let's see, I've got a roll of duct tape in the truck, and I can fix anything with duct tape. Again, this is a steel braided high pressure hose. Probably from looking at it, something that's operating a cylinder. This might be their answer. The hose probably, if you would peel away all the duct tape, has the outer skin cut, and obviously is not blowing oil out under pressure. But this is a no-no.
But you know how things work. We fix it now, I'm gonna fix it tonight, but tomorrow comes and next week and the week, and this becomes a permanent fix, right?
That's exactly right. And when you wrap this, you forget the problem underneath of
You
it.
betcha. So let's move this so we can see it. So we've talked about sunlight, we've talked about abrasion, eating the cords and some of these the casing that we have. Now let's talk about the damages that petroleum type products can do to rubber.
This is the perfect example of using the wrong hose with the wrong product.
Okay.
You know, we mentioned the fact that most ag chemicals, EPDM is a very good product for it.
Mm-hmm.
Petroleum-based products do not like EPDM rubber.
Okay.
They will literally just soak into it and saturate the hose. You could take a hose like this one and it would start leaking through. Even if it didn't burst completely, it's just not a compatible product to the petroleum industry.
So what I see is a lot of these where this hose is moving fluid of some kind, but what's happened is it's leaking, something's leaking on it, and it stays leaked. And it looks like, again, it's just moist and wet, and I've had this now for a long time, and it looks just like it, I mean, you can see it, you can see the oil
Yeah,
just coming.
it's just totally saturated. If you remember the old overhead fuel tanks
Yes.
that were gravity fed,
Yes.
and the hose that hung down from them,
Right.
you have this type of hose on it, and it would literally leak right at the bottom of that curve at the bottom of the
Okay.
hose.
So-
They penetrate it. They're not compatible products, is what it
So
boils down to.
petroleum and our rubber type products, not compatible. Reroute, rechange, come up with something different.
Yeah, use the proper rubber hose.
Okay.
You know, we say rubber hoses, but they're all rubber hoses. It's just different products that they're made out of.
Gotcha. Same idea here.
Exact same scenario here. Again, this is a piece of reinforced nylon. It is not designed for petroleum products. It's saturated, like we're talking about.
Okay.
And it's back to that petroleum doesn't like EPDM or nylon.
Okay, so that's a good take-home point. Let's look at a lot of our hoses have to. It's not just a straight run from A to B. That I've got to have a little bow in it, a little bit of a curve. Sometimes it's a big curve. So these hoses then, by looking at the catalog, it gives me something called a bend radius. And can you explain to me what that means?
All manufacturers have a recommended bend radius on a hose, and what they're trying to do is tell you by their estimate and by their design, that hose can bend around a 2-foot radius or a 6-inch radius, depending on the hose itself. And this particular hose is a steel reinforced hose. It can actually make a tighter radius.
And that's what I'm measuring. That's the radius here.
This is the radius from here to here.
Yes.
If they tell you that a 2-inch suction hose shouldn't be more than a 2-foot radius,
Okay.
then they're talking about from hose to hose when
Okay.
it makes its turn.
Now this is a little bit different on this one. I try to do what you just did, and it looks like, I mean, you could see.
You start seeing it actually kink right at this point and shut off the flow of the hose.
Okay, and you made a point here, if it's wiring and I'm kinking it, which is different than this.
Yeah,
If it's-
the nylon braided hoses such as this one, they're more forgiving. If you kink the hose like that with this one and then straighten it back out, typically it's going to be fine.
Okay.
The flow will return. You kink a steel reinforced hose like that and it's done. It
Okay.
won't straighten itself back out.
Because once the wire bends, it's bent.
It's bent.
All right, one of the questions that comes up is the use of these type of clamps, which are the common clamps that a lot of people
Right.
use, and we got these T-bolt types of clamps here. What's the any preference of one over the other? I
Well-
guess it depends on its use, just like
It depends on its use like everything else. The typical gear clamp such as this one, the Radiator clamp as it's well known, they work very well on small tubing. The T-bolt clamp such as this one, you can't even buy them for anything much less than 3/4 inch.
Okay.
So you got to keep that in mind where you're using it at.
So why is this one a really good one on the bigger hoses?
The reason it's so good on the bigger hoses is its configuration. As you can see, the plate that comes across the boat here.
Yeah, I see it, right, yep.
All right, when this clamp is compressed, as you tighten the nut up
Yep.
on the boat, this whole clamp compresses.
Okay.
We're creating pressure all the way around that wire reinforced or nylon reinforced
Yes.
hose. And so we get a more even distribution around the band itself.
Than the other clamp.
To where the gear clamp, such as this one, it's pulling this tube across that nut. And typically, this area here will have more pressure than the area over here.
Okay, so it brings me up to the double clamping. Any ideas on the double clamping?
Well, double clamping is one of those things that we've all done because we think we're going to have too much pressure or whatever the case is. You have to be aware of what you're clamping. Double clamping works because it does create double the surface area for the clamp. But if you take this and this hose barb as we've got here, if this was short, in other words, let's say this
Right
outer
in here.
edge wasn't there.
Yeah, like right here, take that out.
Right. Trying to put double clamps here, you really don't have room for them. And one of them is going to wind up right on the end of that nipple. And when you do that, what you do is compress the hose around the end of the nipple. And it's not doing you any good at all.
Okay.
Now, a hose barb such as this one, which has a wide surface area here,
Yep.
and you can literally get between these two barbs, you could put one on the inside barb, one on the outside barb.
Okay.
And it will absolutely give you more pressure and more holding power.
And we talked about, especially with these, that we would clamp them and have them opposite, that we might get some benefit of that.
On the gear clamp such as this one, if you put one on this way and pull it down,
Yep.
you're going to have pressure on one side for
Okay.
certain. And reverse the other one and put it on the other way, and that gives us equal pressure on both sides of the
Okay.
hose at two different
Gotcha.
locations.
Very good, the clamping things. Now, the last one is just to talk about what you and I would probably consider a specialty hose, is the anhydrous hose. And obviously, anhydrous is a very good product that we use, but with it comes, some dangers about handling the product.
And anhydrous ammonia, of course, is a product that is very dangerous when handled properly. We have no issues with it. The hose is just one of the elements in that. All anhydrous ammonia hose for the pressure side of the ammonia is a dated hose. And when we say that, it'll have on the hose here itself, it'll say removed before such and such date.
Yep, and this is an old hose we've had around, but it says remove the hose before 2009.
Exactly.
Yeah, but you look at this hose, it looks fine.
This is the thing that really gets people in trouble. Now, our ag retailers, they live and die by that date.
Okay.
I mean, out of date, out of service. It's that simple. Farmers, as we know, who are a little tighter, and they look at that hose and think, well, there's not a kink in it, there's not a rub in it, it's in perfect condition.
Yes.
I don't need to replace that hose, even though it said it should have been off of here 8 years ago.
Yes.
At this point. The issue being, the manufacturers of these hoses put that date on there for a reason, and it's to relieve themselves of the liability of that hose.
And therefore, we don't want to have that liability either.
You don't want to carry that liability yourself. I
So
don't care who you are.
No matter what it looks like, when that date is there, it comes off.
It needs to be replaced, absolutely.
Okay, so that's the key to these hoses then, is to replace them as they're guaranteed.
There's 2 points of replacement here. Damage, hose drags
Sure.
down the road, anything of that nature, get it off. This hose can get you hurt.
Okay, very good. Well, I picked up a couple of neat tips here. Gary, I know you're a busy person, all this equipment, and I do really appreciate you sharing your wealth of knowledge with us and your experience.
Well, we appreciate you having us.
You betcha.
How valuable to have the opportunity not just to have Fred, your experience in talking about don't spring a leak in hoses, but also to have Gary Grant, who's got years of experience of using these hoses in various applications to make sure you get the right product for the right application.
Good.
So Now let's move to the takeaway. The title of the series is Don't Spring a Leak. We know that there are differences in hoses, we know that there are different applications, and we know there's questions that we need to be able to answer when we go for repairs or in design of a product.
Right.
So what's our summary takeaway?
The summary is it's left to us to actually do the inspection on the hoses. Whether we do it in the fall, putting a mothball in it and getting it ready for winter, or pulling it out for spring, we want to reinforce this idea of inspection, and specifically a couple of key points. And those key points is I want to be able to look at a hose and follow that hose as we talked about, and to make sure it's not sitting on things like on this bolt. When this thing vibrates, I'm eating into it.
Look at what we've done with the electronics. This and the others, they're shielded, they're banded together, they're protected. But on the upside, here is a 3,000 PSI hydraulic hose that's rubbing on the edge of a bolt and a nut.
And we have no problems with that.
And when you look by at the outside and you say, well, gosh, that hose is new.
Yeah.
This really looks great. But what you can't see
is right here. What you can't see is right there. So these are obvious visual things that I can check to make sure that I'm not getting wear and tear on that hose. And so whether this was put on after or designed by this manufacturer, you can see what they've done. They've run it through the hole, through this hole here, and they're worried about this rubbing right in here. Mm-hmm. So it's been modified to make it work. Well, a lot of our equipment never was, or we replumbed it and we modified the equipment. And if you can see right here what they've done, here is a major part of rubbing. So they put a piece of rubber there, but they also put a piece of rubber here and got it tied on. Mm-hmm. And the idea is has to be, they had a problem, and was their fix. You can see here they can't reroute it, so they made a sling to where actually they could pull it down and keep it off that piece of metal right here. Mm-hmm. Here, simple idea, you just take another suction hose and you let that suction hose do the dragging on the ground.
Instead of having this being dragged back and forth across the gravel, you put a shield on it.
That's correct, and that's what we're doing. Here, because we know that all this stuff vibrates, they tried to tighten it down so that it would not vibrate as much. Simplest things to do. When I have a place that rubs or has heat, can you see my sacrificial hose here? Mm-hmm. And it happens to be another suction hose. It serves no value except to protect that hose on these rough spots here where it could be rubbing.
Even a little bit of protection up here, and that might even be some gray tape. Who knows?
Well, yeah.
But still, it's a protector.
Looks like a little extra tape needs to be added on because it's been worn off again. So, and we talked about the importance of the clamps. And here is the case of the worm gear. You call them radiator clamps, is what they are. That's all there is, Jeff. Mm-hmm. That's it. I mean, there's nothing more. When you open it up, that's it.
And you know as well as I, if you're putting these on, you can strip this out. It's not the fact, can I go a little tighter, because sometimes there's that breaking point that these treads begin to break free. That clamp's no good to you anymore at that point.
And all you're seeing is the screw fitting into that groove.
Right.
And that becomes a point, that band's not very thick when you just strip it out. So if you're going to do that, carry a couple extra clamps with you because you're going to need them. But by the time that happens, it's blown off. So think about then going to a better clamp, $5, $6, these T-bolt clamp on a lot of our hoses, on pressure hoses. The advantage is you've got two sides on it. You're actually tightening up with metal against metal instead of that little band.
Mm-hmm. And what's better than one? Two.
Yep. And what's the thinking there?
At the same time, here's an application where both of the clamps are at exactly the same position on the clock.
But I would give them an A. I would give them an A for effort. Two clamps, don't disagree with it. But I can improve on that, and what would we do?
And here, you have them in different positions.
Yes.
So your tighten point is at different places. You're doing a better job in making the connection.
Yes.
Don't forget the external environment that this hose is operating in.
Yeah. So here's a case you can see that's just a little groove, and you think, oh, that's not much. But when you take that cover off, you can see I'm actually inside on what's protecting the inside core. So when you see things like that, you may want to stop and take a look at it. Replaces the hoses that are basically deteriorated from sunlight. Why push these hoses anymore? Can I reroute, or can I protect it against heat? Because hoses do dry. And so can I do that sacrificial hose here to try to protect that hose? It's really a bad spot for it to be in. And so, you know, the bottom line is, it's pretty simple. Get the right hose with the design that was meant to meet your needs. It's not just asking, you got a certain size hose. There are a lot of questions to be asked to get it right the first time, and then to follow up with the inspections. That's the key thing, the inspections.
You can trust the manufacturer that they designed it right from the beginning, but it's up to us as operators to make sure that the equipment is maintained. You look at tires, you look at paint, you look at the fuel gauge. Do you look specifically for hoses and the connections that keep you running? That responsibility falls on us. Simple ounce of prevention is worth a pound of cure. Don't spring a leak. That's the title of this series. Dr. Fred Whitford, thank you for being with us here from Purdue University. I'm Jeff Nally, your host for the Legacy Series.